By the way, just to confirm, can you hear me? Let's get started. So first of all, a disclaimer. AP is a trademark registered by the College Board, which is not affiliated with and does not endorse this resource, nor is the 555 team. As usual, this review session was prepared by Reading as part of 55. Led by Lance, 55 is a volunteer serial initiative with more than 70 volunteers and more than 10,000 combined volunteer hours that seeks to provide resources for students taking AP courses. We also have our website, and if you want to apply, you can also check out the application document. And you may ask any question at any time. And we also have an office hour session on Sunday, which is the last session before the AP exam if you want to ask questions. And please participate in activities in chat because this session is mainly writing free response questions. And please use bullet text for answers. And it would be very appreciated if you can fill out the 55 lecture feedback form at the end of the session. That will help me improve my lecturing skills. So here's the table of contents. For ABFRQ, I choose 2 calculator active questions and 2 calculator inactive questions. And then for AP Calculus BC students, we also have 2 BC only FRQs. Let's get started doing the first FRQ. And you can use a graphing calculator. In this question, we're given a table of T in minutes and CT in degrees Celsius. Let's read the question together. The temperature of coffee in a cup at time T minutes is modeled by a decreasing differentiable function C, where CT is measured in degrees Celsius. For T bigger or equal to 0 and smaller or equal to 12, selected values of CT are given in the table shown. So from the first sentence, from the first paragraph, we know that CT models the temperature of a coffee in a cup that decreases over time. Part A approximates the derivative of C at 5 using the average rate of change of C over the interval 3, 7. Show the work that leads to answer and include units of measurement. Let's do part A now, and you may send your answer in the chat with bullet text. I'll be happy to see your steps in approximating the instantaneous rate of change at 5, using an average rate of change of C over the interval 3, 7. A for now. Yes, let's do part A first, and then we'll go on to later parts. And by the way, this is a slide. But please don't read the solution before you do it. I saw some nice answers in the chat, so I think we should go over part A now. This is a standard question of approximating instantaneous rate of change using the average of change. And it literally tells us what the interval is, so we can take a look at those two values, which is 385 and 769. The average of change formula is C7 minus C3 over 7 minus 3. So this is equal to 69 minus 85 over 7 minus 3, which is a negative number. It is expected because the temperature of the coffee in a cup is decreasing. So here is the actual solution. You don't need to simplify, by the way. So anything like this earns a point. And make sure you have the units, because the question tells us that we need to include units of measure. A squiggly line, no, you don't need to. It only awards 1.4 estimate with supporting work. So just this is fine. Or this. Yes, we definitely should include units because the question tells us that we should include units of measure. The main problem is that you must include a difference and a quotient of supporting work to earn the first point. So if you just write 94 without units, just the answer, then you will not earn any points. But if you show the quotient and forgot to write the unit, then you will get 1 point. As joined, we just did part A of the first FRQ, so it didn't make sense much. This is the first part A. Let's go to part B now. I'm going to underline the part that we're currently doing. So let's read part B together. Use a left Riemann sum with the 3 subintervals indicated by the data in the table. So 3 subintervals, which is 0, 3, 3, 7, and 7, 12. To approximate the value of the definite integral from 0 to 12 of function ct with respect to t. And then we need to interpret the meaning of 1 over 12 of this definite integral in the context of the problem. So the problem has 2 parts. How much time I spend per question depends on your progress in the chat. So if I see sufficient answers in the chat, I will move on. Oh, on the actual exam. So on the actual exam, each question is about 15 minutes. Oh, we are doing part B. And this is a calculator active question, by the way. So please use your calculator. Just for the time question for FRQ, the FRQ is 1 hour 30 minutes long, and it has 6 questions. So on average, it is 15 minutes per question. Yes, don't get stuck on the question for too long. What we can first, and then you can try out those that you cannot. If you left the problem alone and read it later, they might find a new way or some insights to. B, this is about integration and approximation using Left-Riemann sum. So I believe it is chapter 6 on the course and exam description. And I've seen some nice answers in the chat already. Of 2 part 7 GG. By the way, for part A, the scoring guideline shows that response that presents only units without a numerical approximation does not earn the second point. So you need to write some approximation in to earn the second point. I just posted a poll in the chat on whether we should go over the solution or not. Who don't have a graphing calculator now, since we're doing the Blue Book online version, you can have access to decimals. So I will decimals first, so you can use the calculator. And you can, if you have a TI-84 calculator at home, you can also bring that onto the exam. And here's the online version. And the poll result is pretty obvious, so let's go over the question now. So this is the official solution. The Left-Riemann sum is the subinterval width, which you can see here. So 3, 4, and 5 as the 3 subinterval widths. And then we pick the left endpoint. So for example, for the first subinterval, we pick the left endpoint, which is the value of C0 for the estimation. And we pick C3, which is the left endpoint, and C7 as the left endpoint. So we can evaluate this because we have the values on the table here. So we pick 100, 85, and 69. I'm just going to put a screenshot in chat just in case you want to look at the question. Yeah, you need to do 3 minus 0 instead of 0 minus 3. We can get 985 as our answer. So 1 point for the form of the left Riemann sum, so you have to write it out, and then 1 point for the estimate. And as usual, you do not need to simplify. Finally, for interpretation, 1 over 12 times the definite integral is the average temperature of the coffee in degrees Celsius over the interval from t equals 0 to t equals 12. And this is the average value formula. So that is the reason for this interpretation. And there are some scoring notes here. If you really want to double check whether your answer is correct or not. Sure. So this is a part B solution. To earn the first point, you need to get at least 5 of the 6 factors correct. And if any of them is incorrect, then you can earn the second point. Interestingly, a response of just this earns both the first and second points, unless you made an error in simplification. So please don't simplify. If you simplify wrong, you get a point deduction. Yes, because this is a left Riemann sum, so we take the left. Just joined, we have lecture sites available here. You can take a look. Slide 8. But please don't take a look at solutions before you're doing it. I'm not sure whether there will be an optimization question. Because I'm for this question, the self-set units will not affect the scoring for second point, and the response need not to include reference to units for the third point. So part B, you don't need to include units. And for part A, if you look at the scoring guideline, these per minute is acceptable. Doesn't explicitly say that, but I would suggest to just write it out to prevent confusion. Session length, I believe, might be over 2 hours. I think we're good with this, so I'm going to send a screenshot just in case you want to see it further. But let's move on to part C now. So let's read the question together. For 12 to 20, the rate of change of the temperature of the coffee is modeled by negative 24.55 e to the power 0.01 t over t, where the derivative is measured in degrees Celsius per minute. Find the temperature of the coffee at time t equals to 20. Show the setup for your calculations. And a reminder that you can use your graphing calculators. And as usual, please send your answer in the chat using Spartans. That will help me see the progress, and I will move on as the correct time. We're doing part C right now. So yeah, if your calculator gives you many decimal places, you would somewhat round it to at least 3 decimal places. By the way, a great way to check your answer is to briefly check whether that matches your intuition or not. As the temperature is decreasing, so at 20, your temperature should be less than 55. Another poll. Whether we should go over the solution now. I think the result is pretty obvious. Let's take a look at how to do part C. We want to get C20. This is what we want. But we're only given C12, which is 55, and a rate of change formula. So a great formula to use is that the change in temperature equals to the definite integral from 12 to 20 is derivative. It's dt up here. I don't have space right. So we can integrate the derivative to get the change. So this is a change, so we have to add it to C12 as well. This gives this answer. So we can integrate the rate of change formula, the derivative of C. So we can evaluate this using a calculator to get this value. So this is 55, we already know. And this should be a negative value because the temperature is decreasing. So we will get 40.329 at the end. So 1 point for the integral, you need to write it out. And you need to use the initial condition for 1 point, and 1 point for the answer. Yes, this is the fundamental theorem of calculus. Here is the solution I posted in the chat. And just in case you have confusion about how scoring works, here are some scoring notes. First point is earned for a definite integral with integrand c prime t. A linkage error, such as this. So here you forgot to put C12 plus, or you just suddenly jump to an answer without writing steps clear, you lose a point for that. And if you miss the differential, the unambiguous responses earn the first 2 points and are eligible for the third point. And some ambiguous responses does not earn the first point, so you lose 1 point for that. And you can earn the third point if the given numeric answer is correct. So I would suggest you put a differential in. And here's the importance of showing work. So just an answer is no points. And as usual, you don't need to simplify. The third point is earned for just like this, with no additional simplification. But you still need to show supporting work, because there's 1 point for integral, 1 point for C12. With that, let's go to part D now. It also reads it together. For the model defined in part C, it can be shown that the second derivative of C is 0.2455 e to the power of 0.01 t times 100 minus t over t 12 to 20, determining whether the temperature of the coffee is changing at a decreasing rate or at an increasing rate. Give a reason for your answer. So here we're given a second derivative, and we want to determine whether temperature is changing at a decreasing rate or at an increasing rate. And we also need to give an answer. The question is, should we write a little sentence itself? Answer. Part D, you can. Reason for your sentence. As usual, I'll be happy to see your responses in the chat with smaller text. Nice, I saw so many smaller texts in the chat. Nice, thank you for all your responses in the chat. Let's take a look at given the second derivative. And basically the second derivative is the derivative of the first derivative. So it reflects the rate of change of the first derivative. So if the second derivative is bigger than 0 on the interval, which it is, because everything is bigger than 0, 0.2455 is bigger than 0, e to the power of 0.01t is bigger than 0, 100 minus t is also bigger than 0, and t squared is also bigger than 0. So this whole function is bigger than 0 on the interval 12 to 12, 20. The rate of change in the temperature of coffee is increasing on this interval. So this only worth 1 point for an answer with reason. The point is earned only for a correct answer with the correct reason that references the sign of the second derivative of c. So you will only earn this point if you indicate this or somehow describe it in words. You must say that the sign of the second derivative is positive. A responder provide reason based on the evaluation of the second derivative at a single point does not earn this point, because it is positive at a single point doesn't mean that it is changing at an increasing rate for the entire interval. So we need to show this for the entire interval. And if you use ambiguous pronouns you cannot earn this point. And you don't need to reference interval, because I think that it is somehow implied. Sure, that's also correct. So if you say to a sentence that shows the same thing, you'll get the point. I'll wait for a bit on this because this is the last question. And please take this opportunity to ask any questions you have. Do that again. And by the way, I'm not sure what happened to your calculator because this is 0.8 something. And because 0.2455 is positive, e to the power of a positive number is also positive. And 100 minus t is positive because 12 and 20 are too little to change this to a negative number. So this is also positive. T squared, that is obviously positive. So, well, positive number getting multiplied and divided together, that will give us a positive number. Question, what if the question asks to show work about the process of y that is bigger than 0? I believe this is sufficient. So you just need to prove that every single thing multiplied together is positive. And you can show them quickly, which is why you don't need to show in this question. And yes, if you integrate the derivative of c, then yeah, because the temperature is decreasing, you should get a negative somewhere. Anyways, that's all for the first free response question. Just to make sure that pace is correct for everyone, Favorite takes just quickly to check whether the pace is correct or not. So I will adjust the time based on the comments. While you're voting, I'm going to show the second FRP. Okay, the votes in the chat is getting interesting. While you're still voting, let me read the question. This should be 2024. Pretty recent. So for the question, a particle moves along the x-axis so that its velocity at time t bigger or equal to 0 is given by vt equals to natural logarithm function of t squared minus 4t plus 5 minus 0.2t. And this is a scalar function, yes, but you can use a graphing calculator for this one as well, because this is question 2. Do part A first. There is one time t equals to tr in the interval from 0 to 2 when the particle is at rest, not moving. We need to find tr. And then we need to answer the question, between 0 and tr, is the particle moving to the right or to the left? Give a reason for your answer. So basically, the question has some 3 parts. First of all, find when the particle is at rest. Secondly, you need to find whether the particle is moving to the right or to the left, and then give a reason for your answer. So make sure you have all parts. Yes, this is the 2024 FRQ. And again, for people who don't have a graphing calculator right now, we have the online decimals, which is used in the exam. If you prefer TI-84 the old way, we also have that. Again, feel free to send your answer with broadcast. There's a poll in the chat asking whether we should go over the solution for part A or not. The calculator for this question. Otherwise, it is going to be a nightmare to solve that equation. So let's take a look. Particle is at rest when you set the derivative of its position to 0, which is velocity. So when the velocity is 0, the particle is not moving instantaneously. So we can evaluate this equation using our graphing calculator. For decimals, it is easier, but for TI-84, you might need to use the 0 option. I believe it is the second option after this. So we can get this answer. So the particle is at rest at 1.426. Or if you just get 1.425, that is also good. This value earns you the first point. And for the second point, you need to say that particle is moving to the right, which is direction. You also need to provide the explanation that the velocity is bigger than 0, or it is positive. So 1 point for the time when the particle is at rest, and 1 point for the direction, which is to the right, with explanation. Point earned for consider Vt equals to 0 and reporting the value. If you find no value or incorrect value, it's not eligible to earn the second point. So you have to earn the first point. So basically you have to find the correct value first. And you don't need to demonstrate an evaluation of Vt at any value of t. It must be correct for a number of digits shown for 1 up to 3 digits after the decimal. So it's for the evaluation, if you do it, then it's going to be a bit smoother than. Yes, a calculator is allowed for this graphing calculator. Velocity is positive because you can see it on the graph. You can use a graphing calculator to graph it. Yes, you can use a graphing calculator. So we have this function back here. Right here. So I might need to use x instead here. Here, between 0 and 2, we see that the velocity, which is this function, it is positive between 0 and 0 here. And we get the value directly from clicking here. Yes, we can use a graphing calculator because this is question 2. This, we can say that the 0 is 1.426 and the velocity is bigger than 0. So that's all for part A. We have 2 points here. Go to part B. Find the acceleration of the particle at time t equals 1.5. Show the setup for calculations. So, first part is to find the acceleration. Second part is to show your setup. Third part is to ask is the speed of the particle increasing or decreasing at time t equals 1.5. And for the fourth part, you need to explain your reasoning. So find the acceleration, show the setup, whether speed is increasing or decreasing, and explain your reasoning. Yes, because this is graphing calculator active, we can cite our calculator. Yeah. It's like, yeah. You don't need to show the algebraic steps to find the answer. Because you get it in the graphing calculator, and that's good enough. Yes, you can do that on decimals and on graphing calculator. Just in case you don't know how to find the derivative, I can set this to, let's say, dx something. This. 1.5. I'm not going to show that. Some examples here. You can put the values in. Or if you want, you can add a slide and change the value too. And for a second derivative, just add another one. Or you can add another one. Oh, for 1D. Let's send an image for 1D quickly. You guys have seen some good answers in the chat already. So let's take a look. So for part B, we can find acceleration using our graphing calculator, just like what I have shown here. You can change this to 1.5. And the I don't think I need to do second derivative, just itself the value. So this is the velocity function. So the derivative of velocity should be acceleration. And at 1.5, it is -1. So we just need to write that back here and say that it is -1. So 1 point for acceleration with setup. The last point of part B, we need to say that the velocity, the speed at 1.5 is a negative number, and they have same sign, so the speed is increasing. That's because the speed is going left and the acceleration is still accelerating left, so the speed is increasing. Oh, that's okay. You can save time for part D. Some scoring notes. So for setup, you demonstrate this relationship. So the question tells us to show the setup, so please do. Otherwise, you will lose a point. And you must say the value based on the graphing calculator. And the second point can only be earned for a response that is consistent with the negative velocity and the present value of A1.5. Make sure your estimation is correct. Don't need to report value. You can just say that it is negative, which is implied here. Because they have the same sign, so this is a negative sign. So this should also have a negative sign, which is implied. And if you present an incorrect value or sign of V1.5, you just not earn the second point. And we also have an alternate solution. Yes, so that is a good analogy. So read it out. So when your curve is moving backwards and your acceleration is also accelerating backwards because the acceleration is also negative. So basically you're accelerating backwards when your car is already moving backwards. So that means that your speed is increasing because speed is the absolute value of velocity. So basically your velocity is getting increasingly negative. So it's getting more and more negative. So its absolute value will get more and more positive. That's why the speed is increasing. And now it's time for part C. The position of the particle at time t is xt, and its position at time t equals 0 is x1 equals to -3. Find the position of the particle at time t equals to 4. Also show a setup for calculations. We have seen a similar problem before, I believe. Let's spend some time doing part C. just join, you can use a graphing calculator because this is calculator active. We'll take a look at the solution later. I've seen multiple good solutions in chat, so let's take a look. So we have seen this question before, I believe. I believe there's the previous of the yeah, this one. They're basically the same, but with a different scenario. So initial value plus definite integral. And for this one, it is also initial value plus definite integral. And the formula line is also very similar. 1 point for integral, 1 point for initial condition, and 1 point for answer. If you made a mistake in rounding, that's okay. Or just your calculator gives inaccurate value. As usual, the first point is earned for definite integral with integrand Vt. Even if the limits of integration is incorrect, you can still earn the first point, but your third point is gone. If you made a linkage error, you lose a point. So those interesting notation because you forgot to put x1 here, or you has a weird jumping answer. And as usual for missing differentials, for unambiguous responses, you're fine. But if the response is ambiguous, you will lose the first point. Second point is earned for is symbolically or numerically adding x1 or -3 to a definite integral with a lower limit of 1. So for second point, you have to write x1 or -3, and the lower limit is 1. That will earn you the second point. And the third point is earned for just an answer of this. That is acceptable with no additional simplification, so just keep it as this is fine. As usual, do not simplify answers, whether algebraic or numeric. usually answer does not earn any points if you doesn't have any subordinate. So this is part C. And for the part A question, this is the answer for TR because the velocity is 0 and the velocity is positive from 0 to that point. So the particle is moving right. Yeah, let's take a look. So that's the last question, part D. Find the total distance traveled by the particle over the interval 1 to 4. Show the setup. I believe some of you already did a part D, so I'm going to take a look. Many people already finished part D. Let's take a look. So for the total distance, it is different from displacement because the total distance traveled. For displacement, if I go right the same amount and go left the same amount, the displacement is 0. But the total distance is not 0 because you traveled that amount of distance. So we need to put the absolute value sign around velocity for integration to get 0.958. And if you do this, that is also acceptable because you're manually shifting the sign yourself. I will do this because that is the simplest possible way. And there's an exemption because the numerical integration techniques are somewhat different. So 0.96 also is the second point. Solve for part D. And for part D, we have 2 points. So 2 points, 3 points, 2 points, and 2 points. Two, two, three, two for this one. Continue. So right now, we're a bit short on time. So I might only be able to do one more AB FRQs. So you have choices. Whether you can do this slope field FRQ about differential equations, or also do this FRQ. I believe it is about fundamental theorem calculus and some integration stuff. So I'm going to make a poll in the chat asking which one you want to do. And for FRQ3, we have differential equations. So if you're not very good at differential equations, this might be more helpful. So we have slope field, we have something about derivatives, which because it involves relative minimum maximum and neither. And then we have separation of variables to solve a differential equation with initial condition, so initial value problem. For FRQ4, we're given a graph and a region R. So this is about integration. So this is a classic integral. We're asked to find some values to evaluate the definite integrals and integration stuff. So let's see which one we want to do. Yes, if you're weak on differential equations, then you might better for you to vote for FRQ3. But if you're weak on integration stuff, you can vote FRQ4. I will just wait for 1 more minute to see. This one, the slope field is provided for you. To sketch it, you need to look at the differential equation. So you can evaluate it at different points. It involves h and t. So, for example, at here, 1, 0, we know t equals to 1 and h equals 0. So I would input that, substitute that into the differential equation with the right side of it, and then sketch the line based on the value you get. And the value you get is the slope of the line. Do some BC reviewing. Well, it's changing. A hint about what BC on the FRQs that we're going to do. They have, for BC FRQ, we have the improper integral and some find the volume of solids of revolution. And for the second BC FRQ, of course, we are going to have sequences and series. That is always the case. Okay, I think right now FRQ3 wins by 1 vote. Sure, because AB topics are also in BC. Vote has decided that we should do FRQ3. Let's read the question first together. The depth of seawater at the location can be modeled by the function h that satisfies the differential equation dh over dt equal to 1/2 h minus 1 times cosine t over 2, where ht is measured in feet and t is measured in hours after noon t equals 0. We're given that h0 is 4. So they plotted it on the plot for us. A portion of the slope field for the differential equation is provided. Sketch a solution curve y equal to ht through the point 0,4. So we just start at 0,4 and sketch a graph. So it might be hard to do because we don't have it on paper. So if you can, feel free to draw the graph. If you can, take a screenshot and annotate it. Here's the solution. You can download screenshot and annotate it. Just to make sure we are doing FRQ3. No calculator, so don't use your calculators now. And we're doing part A of sketching the graph here. So you want to start at 0,4 and sketch the solution curve. I already posted a screenshot of FRQ4 earlier. I'm going to send it to you. And although we'll not go over it, the solution is still on there, so you can try it out and check your answer later. Yes, that is correct. So for free response questions, the test content is digital, but you will be given a free response booklet to write the answers in. That's the case for calculus, AB or BC. Maybe not for some other tests. Yes, I'm going to send you the slideshow here, so you can check it. solutions are after the question. And I ordered them from part A to part C or part D. So I believe it is time to go over part A. And unfortunately, it only works 1 point. But let's see how we're going to draw the solution curve. So those little lines tells us what the instantaneous slope should be. So I can follow it somewhat like something like this. A bit over here. That's a bit of a bit bad drawing, but it is like that. So we need to follow the little lines. And it looks like this. So we need to provide a rough sketch. 1 point, and you must pass through 0.4, and you need to extend to at least 4.5. So at least here. No obvious conflicts with the given slope lines. So for example, you shouldn't draw below like this because you're obviously going against the slope lines. So if you follow it, you'll be fine. Just roughly follow it. This is obviously correct. And only portion of the solution curve within the given slope field are considered. With that, let's go to part B. Let's read the question together. For between 0 and 5, it can be shown that ht is bigger than y. So we're given this condition. Find the value of t for between 0 and 5, at which h has a critical point. Determine whether the critical point corresponds to a relative minimum, a relative maximum, or neither a relative minimum nor a relative maximum of the depth of seawater at the location. Justify your answer. So basically, we have 3 parts. First part, we need to find the value of t, that h has a critical point. Secondly, we need to determine what the critical point corresponds to. And thirdly, we need to justify our answer. So we have 3 parts. I'm happy to see your answers in chat about the 3 parts for part B. Just to double check, I'm going to send the part B. So we're doing part B now. Since we're 1 hour and 30 minutes in the session, I need to send the lecture feedback form again. So if you have to leave, please fill it out. The recording will be posted after the session. Hopefully, soon will be uploaded on YouTube. I don't think rate rates and optimization will fill up them. Because for the next 2 BCF FAQs, we're going to have some BC only topics. And the quick hint for those equation might be stuck on part B. H has a critical point when its derivative is 0 or undefined. So, on what locations might this expression be 0? We're given that ht is bigger than 1 on this interval. So, on what location might this expression be 0? And you can set it to 0 and solve for t. A hint. Then determining which type it is, when given the first derivative, this should remind us of something. I'll go over the solution in about 1 or 2 minutes. Let's take a look. Here is the solution for part B. So because ht is bigger than 1, for this to be 0, h minus 1 can't be 0. 1/2 can't be 0. So the only thing that makes the expression 0 is cosine. We want to make cosine t over 2 equals to 0. The only way to do this within the interval is to set t over 2 equal to pi over 2. So t equals to pi. This is a prerequisite to recognize that for this to be 0, the t over 2 has to be pi over 2. This is a pre-calculus thing, so I hope you still know it. So here's the cosine graph, if anyone forget. This is pi over 2. Pi over 2 or negative pi over 2 will exceed the restriction that t must be between 0 and 5. So we can only pick pi over 2. And Yes, so t equals pi is a critical point. So consider a sine of dh over dt and identify t equals pi worth 1 point each. And then we can apply the first derivative test. The derivative is easier to do because we can check that from 0 to pi it is positive, and from pi to 5 it is negative. So t equals pi must be a relative maximum. For the reasoning, between 0 to pi, it is the derivative is bigger than 0, which means the function must be increasing like this. And then at pi, it is 0. So we have a tangent line, horizontal tangent line. And then it changes to decreasing. So this means that we must have the relative maximum here. This also matches with our curve here, that we can see a relative maximum here. So this double checks our findings. At one point for answer with justification, which is the first derivative test here. And some scoring notes. The first point is earned for considering any of these. And the second point is earned for identifying t equals to pi. And you don't need to have supporting work. You earn without the first one. The justification can be shown by determining the sign at a single value of these two intervals. So you don't need to say this if you evaluate a single value. And you can also use a second derivative test here, which is a bit more tedious, but you can still use it. That's all for part B. And please ask any questions you have any. To find t, first of all, we just set this to 0 because we want to find a critical point. And the critical point means that the derivative is 0 or undefined. Obviously, it is defined at all points. So we have to set it to 0. H minus 1 cannot be 0 because we're given that h is bigger than 1. So h minus 1 is bigger than 0. The only thing that can be 0 is cosine t over t. I set it to 0. And this directly implies from precalculus that t over 2 equals to pi over 2 because of the cosine graph here. Or if you prefer a unit circle, you can also use that. And we solve for t and t equals to pi by some algebra by multiplying both sides by 2. And that is within the range of 0 to 5. And we set the derivative of h to 0. And gives the derivative of h already, because it's a differential equation. dh over dt equals to this. So we set the derivative of h to 0. Because from the first derivative test, so this is the first derivative test, that's the derivative changing from positive to 0 to negative, which is concave down. And if we do a second derivative test, we will find that the second derivative is smaller than 0, so it is concave down, which means that it is a relative maximum. Both are fine. If you show a single value, that is also acceptable. You need to apply actual justification like this, or like the first zero test. So you have to actually show it, like show proof that it is concrete value. Okay, this is for part B. And finally, we have part C left, which is a hard question with a lot of marks. We need to solve a differential equation. Here it is. So part C now. Use separation of variables to solve a differential equation. And we need to find the particular solution when given the initial condition. So, initial value problem for a differential equation. So basically, we're trying to get the equation of the curve we draw here, approximately like this. Might be a bit higher though. We want to find the particular solution to the differential equation with the initial condition h0 equals to 4. This one is a bit harder and takes a bit of time. So I'm going to give you more time to do this. If you find the solution, feel free to send it in chat with Spartans. Please, I'm not talking because I give you time to do the differential equation. I'm not sure. Let's see. Is there a poll in the chat asking whether you're ready to see a solution? So this is a hard question because we need to solve a differential equation. So if you need more time, you can select no. Of this part C versus 5 points, more than half of the entire FFE. I think nobody votes no, so let's take a look. The first step for this is always separation of variables. So we want to separate the variables. So we want to separate t to the right side, and we separate h to the left side. This is extremely important because if you don't do it, you will earn 0 points. This is true. A response with no separation of variables earns 0 out of 5 points. So please do separation variables. And then we can take antiderivatives and put dt, put dA. This is already passing. We just need to put the integral sign. And then we need to solve for it. Each one of them worth 1 point. So this one is 1 point, and this is 1 point. So we have 3 points so far, if we reach this step. And since we're given the initial condition, h0 equals to 4, we need to use a constant of integration, and we just solve for it. So we can substitute h equals to 4 and t equals to 0. So t becomes 0 and h becomes 4. We can do this because we're told that h0 is 4. So from this we can solve that the constant of integration is the natural logarithm of 3. Some of you might do this step at a later stage. That is also fine. So if you did this initially, that is also okay. So some of you might have changed this to this first before doing the constant of integration thing. Both are okay. In this form, if we do this earlier, we get c equals to the natural logarithm of 3. It might be different if you do it at later stages. So this is optional. It is great if you make this argument that deletes the absolute value sign. And then we can use the exponential, change this to exponential form. Because the natural logarithm function is basically logarithm with base e. So I can change it to exponential form. So by e to the power of this entire right side. So this is the particular solution. So h equals to 1 plus 3 e to the power sine t over t. So 1 point for separation variables, mandatory to earn other points. 1 point for one antiderivative and 1 point for the other one. 1 point for constant integration and using initial condition, 1 point for solving for h. Oh, they moved 1 to the right side. So they moved 1 here. So we have 1 plus. And h changes to ht because it is a function, and for abbreviation, just put h there. Algebra steps there. I'm going to take a picture of this because this involves all the crucial steps to solve this differential equation. And I'm going to switch to the story notes page. So square notes is a bit complex. If you forgot the absolute value sign, that is fine. Same here. So the absolute value sign doesn't really matter in this question. And if you forgot to do the constant integration, you can earn at most the first 3 points. And you're eligible for the first point only if you have earned the first point and at least one of the 2 antiderivative points. The first point is about constant integration using initial condition. So if you get this point and this one, but got this one wrong, you are still eligible to earn this if you get this correct. But if you got both of them wrong, then you automatically get one for the first one, and then the fifth one, because the result is eligible for the fifth one only if it has earned the first 4 points. So basically, in summary, if we get the first one wrong, everything is wrong. If you get the first one correct and both of them wrong, then you will definitely get the remaining one. That is what this means. That is still correct. That still counts as constant integration and uses integral condition. And if you put this, that is still correct. This is also correct. And if you present an incorrect separation variables, this is a special case or exemption about what I just talked about earlier. So if you did the separation variable incorrectly, because I put 1 over 2 on the left side, it should be on the right side. If you really want to put it on the left side, you might need to put a 2 here instead of 1 over 2. It does not earn the first point or the fifth one, but it's eligible for the 2 anti-derivative forms. And the first point rule is still this. So this is a special case if you did it wrong. I believe it is AB topic about differential equations. It is still AB. That's all for this question. Most important part is separation variables. Make sure you have it, otherwise you're going to get 0. Make sure you have constant integration, because it gives you an initial value, so you should have it. There are some easy mistakes to make, and you will lose a lot of points. So this is the full solution. And if you have any questions about this topic, please ask right now. We have almost reached the 2-hour mark, so we don't have time for the fourth one. But I still provide the screenshot of solution if you want to do it later. So this is the end of AB FRQs. The later FRQs will be for BC only stuff. So if you're only taking AP Calculus AB exam, then you may leave after finishing the survey. And we really appreciate your feedback. If you're taking Calculus BC, you can stay if you have time. Yes, I believe in you guys that you can get a good score on the AP exam. Taking Calculus AB, you can leave for a month. For instance, if you're interested in what BC is, you can take a look, but let's continue to BC stuff. So for BC, I prepared two FRQs. One which is about this one. This is an integration question. So for the first region of R, it is AB. But for W, it is BC because we're getting an improper integral. And for the volume of solid revolution, I think that's AB still. The FRQ is entirely BC only. Yes, the part C is not, because it is an improper integral. This is FRQ 5. The FRQ 6, this is about Taylor series, Lagrange error bounds. Since I only have time for one now, so I'm gonna make a poll on which one I want to do. FRQ 5 has the first two questions are AB. The third one is BC, and for FRQ 6, it is entirely BC only. And FRQ 6 seems standard because it is almost always about sequencing a series. Yes, the sixth FRQ is entirely BC only. And the fifth one has some AB topic in the first two questions. And for the spoiler tags, double absolute value sign. Like this. And put it into your chat USC spoiler tag. Wait for a bit on which FRQ you decide to do. Because the vote is changing quickly. And even if we didn't do one, it is still on the slideshow, so you can review that later if needed. And for questions, you can ask in the AP Calculus AB or BC channel. So right now, the AB part is already over. So whether it covers AB or BC depends on which FRQ we choose. Because FRQ 5 involves two AB questions about integration and solids of revolution. But the sixth FRQ is entirely BC only. Preferences because it depends on what you guys want to do. Part C of FRQ 5. That is somewhat, yeah. That is the formula we use. Clara squared. But you're going to deal with the improper integral. Both seem to stay for a bit. I'm going to wait for just 1 minute for the call. Okay, time is up. Let's see the polygons. It seems like FRQ6 wins. So unfortunately, there will be no AB topics now. But if you misses the previous ones, you can still look at recording later, which should be uploaded to YouTube. Let's take a look at this FRQ6 about sequence series. Function f has derivative of all orders for all real numbers. That's very good for Taylor polynomial, for Taylor series, and it is known that f0 is 2, f prime 0 is 3. The second derivative of f is negative f x squared, and the third derivative of f is negative 2x times the derivative of f x squared. Very interesting stuff going on here. Find the fourth derivative of f x, the fourth derivative of x with respect to x. And then we want to write the fourth degree Taylor polynomial for f about x equals 0. Show the works of these two answers. So we're given 4 equations, and we want to find the fourth derivative, and then write the fourth degree Taylor polynomial, and show the work. Feel free to try this out on your own, and then we will take a look at the solution. Oh, I think the part B involves integration by parts. It's not really AB. But anyways, let's focus on part A of FRQ6 for now. I'm going to take a look at it later. And if you're still stuck on how to start, the fourth derivative of x is the derivative of the third derivative. So we want to differentiate negative 2x times the derivative of f(x squared) by using product rule and chain rule. That will be the hint if you haven't started yet. By the way, just put a poll in the chat asking whether you're ready to see a solution. If you're still working, you can select no. And for those who just joined, we're doing the part A of this FRQ. This is BC only FRQ. Everyone selects Yes. No one likes no, so let's take a look. So we want to take the derivative of this thing, which is a product, so I will apply the product rule. So this is the result of the product rule. And a result of a chain rule right here. So 1 point for the formal product rule, 1 point for the answer for the fourth derivative. So we have -2, which is the derivative of the first term, times the second term, and copy the second term down, plus the derivative of the second term, which is do a second derivative here. We need to apply the chain rule as well, and then times the first term. So that's the origin of this answer. Then, for the last 2 points, we have 1 point for the two terms of polynomial, 1 point for remaining terms. So if we get two terms correct, you'll get 1 point, and if we get remaining terms correct, you'll also get 1 point. This is a standard Taylor polynomial question. So I hope you all still remember the general term of a Taylor polynomial. This is actually Maclaurin because the center is at x equal to 0. So it is going to be from n to 0 to infinity, a fraction of the nth derivative, 0 here, because it's Maclaurin. And the x profit, because its center is at 0. So we can use this general term to get the remaining terms. Some scoring notes. The first point is earned for a correct fourth derivative, or for a form. And the second point is earned only for a completely correct expression. And a response that earns the first point but not the second may evaluate the present expression and use a consistent non-zero value. So this means that if you get this wrong, so if you get this one, but not the second one, you can use the wrong answer to get the coefficient. If this is consistent with your finding, then we'll earn the point. And if your polynomial includes a non-zero third degree term, which is obviously false, because the third derivative is 0, any terms of degree greater than 4, because it's only asks for fourth degree, so don't go above, or the notation of plus for remaining ones, because it only asks for a fourth degree Taylor polynomial, so we stop at 4. If you include any of those, you do not earn the fourth point. You can still earn the third point though. So that's all for part A. Let's take a look at part B now. Part B. The fourth degree Taylor polynomial for f about x equals 0 is used to approximate f 0.1. Given that the fifth derivative of f is smaller than or equal to 115 between 0 and 0.5, use the language error bound to show that this approximation is within 1 over 10 to the power 5 of the exact value. This is a classic question using the error bound. Let's try this out. No, I'm not talking, but I'm talking now. So we are currently doing part B of the FRQ. And I'll have this here answered in chat. And for those of you who might forget what the language error bound is, it basically states that the error is the next term, but it is a bit more complex than that though. That's the kind of the essence. The same with alternating error bound. I'm gonna send a definition from a textbook in the chat. Fourth degree polynomial, that is the one we calculated in part A. This is called the fourth degree Taylor polynomial. But that is not really relevant for part B though. We don't need that, because the error bound is the next term. Yes, the language error bound caps the maximum error. So it basically equals to the next term with the maximum possible derivative value. Let's take a look at this. So the error bound is the next term. So we stop at 4. So the error bound is the fifth term. The fifth term is f5. Over a factorial and then x to the power of n. Not exactly the next term, because we need to bound the maximum value of this derivative. Because the error bound is always positive. So we have value of c here. The c is between 0 and 0.1. This is the error. But to cap the error, I must find the maximum value of this derivative, which is given. And I need to change n to 5 here because we're looking at the fifth term. Yes, for Taylor series, there are infinite number of terms, so there is always an error for finite number of terms, but they're exact. On the fifth term, even if you use the fourth 5 terms, which is fourth degree, you can still get within 1 over 10 to the power 5, which is sufficient for real life applications. But anyways, let's take a look. So the maximum cap is 15. So the error will be 15 over 5 factorial. The x here is 0.1, so 0.1 to the power of 5. Take a look. This is the direct application of the Lagrange error bound. So the maximum of the derivative, the fifth derivative, from 0 to 0.1, is the next term, so it's 5 and 0.1 to the power of 5. And the fifth derivative. So it's basically the maximum possible value of the next term. And it is obvious that the error is less than 1 over 10 to the power 5. So this is a 2-point function. The first point is earned for just this expression. If you simplify wrong, you will not earn the second point, unfortunately. But if you write this, you will earn the first point. To earn the second point, you must show the inequality. And please don't write that error equals to this, because this is an error bound, not the actual error. This is the maximum error possible. This just guarantees that the maximum between 0 and 0.1, between 0 and 0.1 is 15. This is a bit more extreme, but that's fine. It covers the interval we want, which is between 0 and 0.1. This is a part B, and we should take a look at part C now. The new function g, that g0 is 4, and the derivative of g equals to e to the power of x fx. Write the second degree Taylor polynomial for g about x equals 0. We need to write another Taylor polynomial. So this is somewhat similar to the first one, to part A. You will do this on your own, and if you find the answer, you can send it in the chat. But this is for BC. We're approaching the end, that's fine. But the recording will be posted on YouTube if you missed the previous AP class. Let's take a look at part C. So this is very similar to part A. They follow the same steps. So we want to get a second degree Taylor polynomial, so we have to get a second derivative because it is required. So also polynomial. So it is for part A we also use a polynomial, so it's very similar. And we evaluate the derivatives at 0 to get 2 and 5. So it is 4 plus 2x plus 5 over 2 factorial x squared, which is just 5 over 2x squared. So 1 point for second derivative, 1 point for first two terms, and 1 point for Taylor polynomial. So here are some square notes. Yes, we have 3 points for part C. Part B is 2 and part A is 4. Interesting. Part B is a bit shorter if you know how to do the error bound. Part B is a bit more complex because you need to use a chain rule and deal with some things. Interesting. So 3 points for part C. Even if you cannot get the second derivative, you can still get the second point. Because if you evaluate g prime 0, you get it 2. So you definitely should be able to get the first two terms without thinking much. That is fine. I would suggest you show the substitution note. Not really point allocations yet. Because they want to take a look at the first two terms of the polynomial. With or without any support number. So I don't think they even care about that. It depends on your preference, but the trickiest part for me is for BC parts is the language error. Yes, we have a question today for tomorrow. So that would be perfect for tomorrow, if you have time. But I went over that in Unit 10 lecture. So you can access the lecture on YouTube. And also have the slideshow available on lecture schedule sheet. And the ratio test is mainly for to determine the radius of convergence that is often used. There are also other tests as well. Yes, if it equals 1, then we are screwed. And for Euro series, we only use ratio test first if there is a factorial or power of n. So it's easier to get the results. The slideshow should have all the tests tested on the exam. Because I haven't seen an interim test for divergence for a while. Anyways, this is the part C. It's so similar to part A, so they have 7 points for 2 similar questions. Anyways, we have reached the end of the session because we went over everything. Oh, here are some extra scoring notes if you're interested. Yes, it is 9 a.m. in my time zone as well. Pacific Daylight Saving Time. I'm trying to pace the eventually. You can see that on the events. Oh, here. Yes, this link should adjust your time zone. And so that office hour session will be the last one before the exam. This lecture is trying to hold some post-exam release FAQs after the release. And yes, that's all for this session. I posted some resources still at the back. And as usual, please fill out the survey. Your feedback is greatly appreciated and will help me improve my lecturing skills for other students as well. It's my pleasure to tutor all of you. This weekend, everyone, I hope you will ace the AP Calculus AP BC exam on Monday. And if you have any further questions, you can ask in the AP Calculus AP BC channel if you don't know that yet. If you can't see those 2 channels, you need to get the roles. You can go to role sign up if you can't see those channels. Again, the office hour session is tomorrow at 9 a.m. Pacific time, and the event link should automatically adjust to your time. And that's all for this session if you have filled the lecture feedback form out. Bye everyone. I'm going to stop the recording now.